Every era in Earth's history has had its own rulers. On land, they were giant carnivorous dinosaurs, and in the deep oceans, they were apex predators. Two of the greatest predators that ever existed were the Megalodon, a prehistoric shark, and the Kronosaurus, a colossal marine reptile. The question, who would win, has captured the public's imagination. However, a scientific investigation reveals that this is not just a story of a hypothetical battle, but a deeper narrative about the succession of underwater dynasties separated by a huge span of time. The Megalodon's era. Let's begin our story not in a monster thriller, but in a scientific investigation of one of the most successful predators in Earth's history. The world of the Megalodon, scientifically named Otodus megalodon, formerly known as Carcharicles megalodon, was the world of two geological epochs, the Miocene and the Pliocene. About 23 million years ago, as the Miocene began, Earth was significantly warmer and wetter than it is today. Higher sea levels created shallow, warm, and nutrient-rich seas that allowed life to flourish. This was an ideal environment for a giant predator, a world with an abundance of large fish and early whales to hunt. The fossil distribution of the Megalodon is a testament to its absolute dominance. Fossils, primarily teeth, have been found on every continent except Antarctica. This global fossil record isn't just a simple geological fact, it's proof of the shark's extraordinary adaptability and its undeniable position at the top of the food chain. A species with such a global distribution must have been able to withstand diverse conditions and employ a flexible hunting strategy. This suggests the Megalodon was not a specialized predator limited to one habitat, but a large predator that could exploit many different food sources across the oceans. This widespread distribution implies that it was the undisputed apex predator of its time, unchallenged by local competitors until later stages of evolutionary history. Another crucial finding about its biology is the existence of nursery grounds for its young. Fossils suggest that the Megalodon established areas for its juveniles in shallow, food-rich seas, such as the Gatun in Panama. While these shallow coastal waters offered protection from deep-sea predators, they created a critical weakness. A species that relied on such well-defined habitats would have been less resilient to global environmental changes. When the cooling period of the Pliocene began, these coastal areas would be the first to be affected, either by a drop in sea levels or by changes in prey populations. This suggests that the species' decline began with its most vulnerable members, the young, long before the adults had to face resource scarcity in the open ocean. The popular image of the Megalodon often depicts it as a colossal version of the modern great white shark. However, recent research has clarified this notion. Based on the analysis of a nearly complete vertebral column found in Belgium, scientists have created a new, more accurate, and perhaps even more terrifying model. While previous estimates placed its length between 50 and 60 feet, a recent study in 2025 proposed a potential size of up to 80 feet and a weight of up to 94 tons. To help visualize this, that size is equivalent to a bus or a modern blue whale. Interestingly, this recreation also changes the Megalodon's body shape. Instead of the great white's bulky build, it likely had a sleeker, more slender body, similar to that of a modern lemon shark. This shape would have made it a more efficient swimmer, a critical trait for an animal of such monstrous size. It's also believed to have had a shorter snout compared to the great white, with a flatter, almost squashed jawline, and extremely long pectoral fins to support its immense weight. The shift from a great white-like model to a lemon shark-like model is a profound reinterpretation of the shark's biology. Research shows that a great white shark scaled up to the size of a megalodon would have struggled to swim. Therefore, to achieve its monstrous size, the Megalodon must have evolved a more energy-efficient body structure. The reason for the giant great white shark misconception stems from an outdated scientific classification that has since been debunked. For years, the Megalodon was placed in the same genus as the great white shark, Carcharodon. However, scientists now believe it belongs to a separate lineage, Otodus, that originated more than 100 million years ago. This makes the ancestor of the great white a contemporary and possibly a competitor rather than a direct descendant. This fact has changed the story from a simple evolutionary succession to one of two different lineages competing for the same resources, a key factor that eventually led to the Megalodon's extinction. The Megalodon's true power lay in its jaws. With an estimated bite force of 108,514 to 182,201 newtons, or up to 40,000 psi, it was one of the strongest biting predators known. For comparison, a great white shark has an estimated bite force of only 18,216 newtons, and a human has 1,317 newtons. With a jaw spanning 9 to 11 feet wide, it could have swallowed two adults standing side by side. This colossal jaw was equipped with 276 teeth, each up to 7 inches long, with serrated edges. Its hunting strategy is revealed through fossilized whale bones. Scientists found evidence that it used its bite force to sever the fins and tails of its prey, immobilizing them before delivering a final, lethal blow to the softer underside. This detail suggests the Megalodon was a tactical predator, not one that relied on brute force alone. An animal of its size and power could have inflicted significant damage on its prey with just one bite. Yet the evidence shows that it chose a calculated approach to minimize risk and energy expenditure. Disabling a massive whale first would have made the hunt much safer and more efficient. This implies that despite its immense power, the Megalodon was a smart hunter, not just a savage monster. Another significant physiological advantage was that the Megalodon was likely regionally endothermic or warm-blooded. This ability would have given it a key advantage, allowing it to swim faster, dive deeper, and hunt in colder waters where its primary prey, such as large whales, lived. However, this trait also came at a steep cost, a huge energy requirement to maintain its body temperature. This reliance on a high energy intake became a crucial factor in its eventual extinction. The ability to maintain a high body temperature gave the Megalodon a major advantage, but also made it an energy-intensive animal. When global cooling began and its primary food source whales migrated or declined, the Megalodon's energy needs could not be met. The very trait that made it a dominant predator also sealed its fate in a changing world. The Kronosaurus's reign. To understand this predator, we must travel back over 60 million years to the early Cretaceous period. This world was completely different from the Megalodons. The Mesozoic era was ruled not by sharks, but by marine reptiles. The environment of the early Cretaceous was a warmer, wetter world with higher sea levels and vast inland seas covering continents. The specific habitat of the Kronosaurus was the frigid, high-latitude Eromanga Sea, which covered a large part of inland Australia. The dominance of marine reptiles like the Kronosaurus reinforces the temporal gap between the two species. The Megalodon and its relatives were not yet on the scene. The story must make it clear that these two animals represent different apex predator dynasties. The Mesozoic was the age of marine reptiles. Their dominance in the fossil record highlights the complete difference of the ecosystem at that time. Ancient sea lizards, ichthyosaurs, and plesiosaurs filled the highest ecological niches, a role that would later be taken over by sharks and whales. An interesting historical detail concerns the Kronosaurus skeleton at the Harvard Museum of Comparative Zoology. which paleontologists jokingly called Plastosaurus. This was one of the pioneering reconstructions, but it was highly speculative and exaggerated the animal's length to around 42 feet. The size accepted by modern science is between 30 and 36 feet. Anatomically, the Kronosaurus was a typical plesiosaur, a short neck, a sleek, teardrop-shaped body, and a massive crocodile-like head. Its huge skull could be up to 8 feet long, containing a powerful jaw with large, conical, crushing teeth. It also had a unique method of locomotion. Its 4 limbs were modified into flippers, allowing it to fly underwater, potentially maintaining high speeds for long periods. The mention of the Plastosaurus controversy shows a deep understanding of the scientific process. It shows that paleontology is not a field of static facts, but one of constant refinement as new evidence emerges. This story of an inaccurate but historically significant reconstruction is a powerful metaphor for how we continuously improve our understanding of these ancient creatures. This adds depth and authenticity to the report. The Kronosaurus was the apex predator of the Eromanga Sea, an undisputed position in its ecosystem. Based on fossil evidence, its diet was diverse, including large fish, invertebrates like squid and ammonites, and other large marine reptiles such as sea turtles and long-necked plesiosaurs, elasmosaurids. One specific piece of evidence is a crushed skull of an Eromangosaurus with bite marks that match the teeth of a Kronosaurus. That doesn't mean the Kronosaurus had no rivals. It faced competition from other predators, including a shark species similar to a Cretaceous. Furthermore, fossil evidence also shows aggression between individuals of the same species and even cannibalism, with bite marks from an adult found on a juvenile. The diet and habitat of the Kronosaurus were fundamentally different from the Megalodons. It hunted marine reptiles and hard-shelled invertebrates, prey that didn't exist or weren't dominant in the Megalodon's era. This shows that the two animals evolved to fill similar but separate ecological roles in completely different food chains. This highlights the scale of change in life over geological time. Evidence of competition with a shark and cannibalistic behavior shows a fiercely competitive environment, reinforcing the idea that even the life of an apex predator was a brutal struggle for survival. The giant gap. The 60 million year gap is the core point of the story. The Kronosaurus and the Megalodon were separated by a massive period of geological time. The Kronosaurus went extinct about 66 million years ago, while the Megalodon only appeared about 23 million years ago. The cause of the Kronosaurus's extinction was the Cretaceous Paleogene, KP, mass extinction event, triggered by a massive asteroid impacting Chicxulub. The impact caused a global impact winter, blocking sunlight, destroying photosynthetic organisms, plankton, and causing a rapid collapse of the marine food chain. This event killed all non-avian dinosaurs, as well as marine reptiles like plesiosaurs, including the Kronosaurus, and mosasaurs. The KPG extinction event was an instantaneous global catastrophe that wiped out an entire ecological structure and its apex predators in a geologically short period. The Kronosaurus had no time to adapt or evolve. It was a victim of a system-wide collapse. This is in complete contrast to the slow, multi-factor decline of the Megalodon. In the period immediately following the KPG event, the oceans were a desolate place, with many ecological niches left vacant. It took a long time for biodiversity to recover, but this ecological void eventually allowed new life forms to flourish. A few shark species survived the extinction, perhaps due to their unique physiology and reliance on different food sources. This paved the way for their lineage, eventually leading to the emergence of the Otodus family of giant sharks, culminating in the Megalodon. The KPG event, while devastating, was a necessary prerequisite for the development of the Megalodon's world. Without the asteroid impact that killed the marine reptiles, it's highly unlikely that conditions would have been right for a new lineage of giant sharks like the Megalodon to evolve and dominate. The extinction of the plesiosaurs created the ecological space for new apex predators. This causal relationship, where the collapse of one species creates an opportunity for another, is a powerful evolutionary theme. It reinforces the idea that the Kronosaurus and the Megalodon were not rivals, but successive rulers of the ocean. The hypothetical showdown. This hypothetical confrontation would be unfair. The Megalodon's overwhelming advantage lies in its size and power. At double the length and potentially many times the weight, the Megalodon would be an overwhelming opponent. Its bite force, estimated to be up to 40,000 psi, was a lethal weapon. It could inflict catastrophic damage in a single attack. Physiologically, the Megalodon had the significant advantage of being a fish, not needing to surface for air. This would give it long-term endurance in an extended fight. Furthermore, its regional endothermy could have given it greater swimming speed and stamina compared to its reptilian opponent. In contrast, the Kronosaurus had its own advantages. As a reptile, it may have had a larger brain and a greater problem-solving ability than a shark. Its four-flipper locomotion could have given it more agility in sudden lunges, and its ability to breathe air would allow it to rest at the surface. While its bite force was much lower, it was still a formidable weapon. Its jaws were built for hunting other animals, suggesting a different tactic. However, in a direct confrontation, the Kronosaurus's advantages would not be enough to counter the Megalodon's superior size and strength. With its ability to paralyze its prey with a single bite to the fins, the Megalodon could easily immobilize the Kronosaurus before finishing it off. The Kronosaurus would be like a giant reptilian mammal in a world of sharks and would be at a huge disadvantage in a direct confrontation with a much larger, heavier, and more powerfully armed creature, the legacy of giants. And so, the hypothetical showdown between two ancient rulers of the ocean comes to a close. The Megalodon, with the immense size and power of a shark, would have convincingly won against the Kronosaurus, the mighty warrior of the marine reptile era. This confrontation is not just a hypothetical scientific question, but also a testament to the continuous evolution of life on our planet. The Megalodon and the Kronosaurus were not rivals, but successive rulers of the ocean. One was the reptilian giant of the Mesozoic era, a victim of a cosmic catastrophe. The other was a shark of extraordinary power, a victim of a changing world that it was too specialized to survive in. However, the most thought-provoking part is that both of these giants have disappeared, making way for new predators. Their stories remind us of the fragility of life, even for the most powerful creatures. We live in a world where evolution and extinction are always at play, and only the best adapters can survive. If you are also captivated by stories of the primeval world, where giant monsters ruled, then this is the channel for you. Hit the subscribe button now so you don't miss the next documentary videos, where we will explore the deepest mysteries of natural history and paleontology together. And don't forget to hit the bell icon to get notified as soon as the newest videos are out. Leave a comment below and let us know which giant you want us to put in the arena next. Will it be the T-Rex and Triceratops, or another incredible matchup? Thank you for watching. We'll see you on our next adventures.